In this video, we're going to focus on a few GRE math type questions. And for each of these questions, make sure you pause the video and try the problem yourself before viewing the solution. And then after you try it, after you select your answer, unpause the video to see what the solution is. So let's begin with this problem. Which of the following answer choices is correct? Is the quantity in column A greater? Is the one in B greater? Are the two quantities equal? So we have a comparison type question. And let's convert each quantity into a single number. So let's start with the left side. 8 squared is equivalent to saying 8 times 8. You're multiplying two 8's together. 8 times 8 is 64. 5 squared, or 5 times 5, is 25. And 64 minus 25 is 39. Now, according to the rules of order of operations, we need to work on what's inside of the parentheses before we apply the exponent. 8 minus 5 is 3. 3 squared, which is 3 times 3, that's 9. So we can see that 39 is greater than 9. So the quantity in column A is greater compared to the quantity in column B. So answer choice A is the correct answer. Number 2, what is the arithmetic mean of the values 34, 75, 51, 68, and 47? The arithmetic mean is basically the average. To calculate the average of a set of numbers, what you need to do is find the sum. You need to add all the numbers and simply divide by n, which is the amount of numbers that you've added. So there's 5 numbers, therefore n is equal to 5. And let's add up the numbers. 34 plus 75 plus 51 plus 68 plus 47. So if we add the 5 numbers, it's equal to a sum of 275. And let's take this number divided by 5. 275 divided by 5 is 55. So this is the arithmetic mean, or the average, of the 5 numbers. So C is the right answer in this problem. Number 3, if x plus 2y equals 13 and 3x minus 2y equals negative 1, what is the value of 5x plus 4y? So what can we do here? How do we solve this type of problem? So on the left, we're given 2 equations. And using these 2 equations, we can solve for the values of x and y. Once we have the values of x and y, we can plug it into this expression to find the value of 5x plus 4y. So let's go ahead and do that. Let's write the 2 equations in order. Let's line it up. Let's put the x and y variables next to each other. Notice that we can solve this system of 2 equations using elimination. If we add the 2 equations, x plus 3x, or 1x plus 3x, is 4x. 2y plus negative 2y, they cancel. That's simply equal to 0. And 13 plus negative 1, which is 13 minus 1, that's 12. So now if we divide both sides by 4, we can see that 12 divided by 4 is 3. So now we have the value of x. Now we can take this value, plug it into the first equation, or even the second, and that can help us to find the value of y. So let's replace x with 3. So 3 plus 2y is equal to 13. Now let's subtract both sides by 3. 13 minus 3 is 10. So 2y is equal to 10. We've got to bring this down. And now let's divide by 2. 10 divided by 2 is 5. So now we have the values of x and y. But we're not finished yet. Now what we need to do at this point is replace x and y with 3 and 5 using this expression. So it's going to be 5 times 3 plus 4 times 5. 5 times 3 is 15, 4 times 5 is 20, 15 plus 20 is 35. Therefore, the expression 5x plus 4y has a value of 35. Therefore, E is the correct answer. Number 4. 7 apples and 5 bananas cost $6.30. 11 apples and 7 bananas cost $9.60. Based on this information, how much will 15 apples and 13 bananas cost? So like the other problem, the last one, we can use a system of equations to solve it. So let's write the two equations that we need. 7 apples, A represents the number of apples, B is going to represent the number of bananas. So 7A plus 5B is equal to 6.3. 11A, 11 apples, and 7 bananas, or 7B, is equal to $9.60. So how can we solve for A and B in this equation? Let's focus on B. Let's cancel it. Right now, if we add it, 5 and 7 is 12, so we can't add right now. We need to adjust the two equations in such a way that we can cancel the B variable. The least common multiple of 5 and 7 is 35. So we're going to multiply the first equation by 7 and the second equation by -5. Now everything in the first equation has to be multiplied by 7 for this to work. So 7 times 7a is 49a. 7 times 5b is 35b. 6.30 times 7 is $44.10. Now for the next equation, let's multiply everything by -5. -5 times 11 is -55. 7b times -5 is -35b. $9.60 times -5, or 9.6 times -5, that's -48. So now we can add the two equations, because if we do so, the b variables will cancel. 35b plus -35b adds up to 0. Now 49 plus -55, that's -6. So we have -6a. 44.1 minus 48, that's -3.6. So now we need to divide both sides by -6. -3.6 divided by -6 is 0.6, and that's A. Actually, a mistake was made. 44.1 minus 48 is not 3.6, but rather it's 3.9. So if we divide by -6, -3.9 divided by -6 is 65.65, that is. So the cost of each apple is 65 cents. So now we need to find the cost of each banana. So let's use the first equation to do that. We're going to focus on the equation before we multiplied it by 7. So 7a, or 7 times 65 cents, plus 5b should equal $6.30. Now 7 times 0.65 is 4.55. And if we subtract both sides by 4.55, we'll see that 5b is equal to $1.75. So now let's divide both sides by 5. So 1.75 divided by 5 is 0.35. So each banana sells for 35 cents. Now, we can find the value of 15 apples and 13 bananas, now that we have the cost of each apple and banana. So 15 apples is simply going to be 15 times 65 cents, and the cost of 13 bananas is just 13 times 35 cents. So let's do this one step at a time. 15 times 0.65 is $9.75. 13 times 0.35 is $4.55. Adding these two together, 9.75 plus 4.55 will give you $14.30. So this is the cost of 15 apples and 13 bananas. So therefore, answer choice C is the correct answer. Number 5. Which of the following values of x is a solution to the equation x squared minus 2x is equal to 15? So what do you think we need to do here? All we need to do is solve the equation. Now, the best way to solve it is to factor the expression. To do that, let's move the 15 from the right side to the left side. It's positive on the right side, but once we move it to the left side, it's going to become negative 15. Or you could just subtract both sides by 15. So we now have the expression x squared minus 2x minus 15 is equal to 0. Now how can we factor a trinomial, which is a polynomial with 3 terms? How can we factor it when the leading coefficient is 1? To do that, here's what you need to ask yourself. What two numbers multiply to negative 15 but add to the middle coefficient negative 2? We know that 15 is 5 times 3, but which one is positive, which one is negative? We can do 3 and negative 5, or negative 3 and 5. Negative 3 plus 5 is positive 2, but positive 3 plus negative 5 is negative 2. So therefore, it turns out that you can factor it by simply writing the numbers plus 3 and minus 5. So it's x plus 3 and x minus 5 is equal to 0. Now, if you ever feel unsure about your answer, you can FOIL it to see if you get the original expression. X times x is x squared. X times negative 5 is negative 5x. 3 times x is 3x. And 3 times negative 5 is negative 15. So if we add negative 5x plus 3x to two like terms, that's going to be negative 2x. So as you can see, we do indeed get this expression, which means that what we did was the correct way to factor the expression. So now what we're going to do is set each factor equal to 0. So x plus 3 is equal to 0, and x minus 5 is equal to 0. So if we subtract both sides by 3, we can see that x can be negative 3, or if we add 5 to both sides, x is equal to positive 5. Now positive 5 is not one of the solutions. It's not the same as negative 5, so answer A is not correct. Negative 3 is a solution, and it matches with answer choice B. Positive 3, we don't have that. So B is the right answer in this problem. Which of the following values of x is a solution to the equation 6x squared minus x minus 12 equals 0? Select all that apply. Whenever you see this statement, keep in mind you could have multiple answers. It might be one answer, two answers, three answers. You need to know all the ones that are correct. So let's go ahead and factor this expression. In this example, the leading coefficient is no longer 1, it's 6. When it's a number other than 1, there's going to be more work involved, so to speak. What you need to do is multiply the leading coefficient by the constant term. 6 times negative 12 is equal to negative 72. Next, find two numbers that multiply to negative 72 but add to the middle term or the middle coefficient negative 1. If you don't see a number, there's a 1. It's invisible. So what two numbers multiply to negative 72 but add to negative 1? 8 and 9 multiplies to 72. Now we can use negative 8 and positive 9 or positive 8 and negative 9. Now positive 8 and negative 9 adds up to negative 1. So that's what we need to use. So what we're going to do at this point is replace negative 1x with negative or positive 8x and negative 9x. And then we're going to factor by grouping. In the first two terms, let's take out the GCF, the greatest common factor. The greatest common factor of 6 and 4 is 2. 6 and 8 is 2. 6 and 8 are both divisible by 2. And the greatest common factor of x squared and x, it's the smaller of the two, it's just x. So if you divide 6x squared by 2x, that's going to be 3x. 8x divided by 2x is equal to 4. Now, in the last two terms, let's take out the GCF. 9 and 12 are both divisible by 3, but it's going to be negative 3. Negative 9x divided by negative 3 is 3x. Negative 12 divided by negative 3 is plus 4. The reason why you want to take out negative 3 is because it gives you a common factor of 3x plus 4. You want those two to be the same. If they're the same, you're on the right track. If they're not, you need to go back and check your work. A mistake was made. So when you see these two terms, in the next line, write it just once. And then what goes on the inside of the second parentheses is what you see on the outside here, 2x minus 3. And so now it's factored. You can FOIL this expression to confirm that it's indeed equal to the original expression, which it is. Now let's set each factor equal to 0. So for the first equation, let's subtract both sides by 4. So those two will cancel. And so 3x is equal to negative 4. Next, let's divide both sides by 3. So x is equal to negative 4 over 3. So E is an answer choice. Let's see if we have another answer. So now let's add 3 to both sides. And so we have 2x is equal to 3. And now let's divide both sides by 2. So x is equal to 3 over 2. So B is the other answer. Now, if you ever get to a situation like this and you're having trouble finding how to factor it or finding the answers, you can always use the quadratic equation. So let's confirm our answer with the quadratic formula. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. A is the number in front of x squared. A is 6. B is the number in front of the x, which is negative 1. And C is negative 12. So this is negative 1 plus or minus b squared. Negative 1 squared, which is negative 1 times negative 1, that's positive 1, minus 4 times a times c, divided by 2a, or 2 times 6. Negative times negative 1 is simply positive 1. Negative 4 times 6 is negative 24. And if you multiply that by negative 12, that's 288. 2 times 6 is 12. Now 1 plus 288 is 289, and the square root of 289 is 17. So now at this point, notice the symbol plus and minus. That's going to give us the two answers. So the first answer is going to be 1 plus 17 divided by 12. And for the other one, it's 1 minus 17 divided by 12. So 1 plus 17 is equal to 18, and 1 minus 17 is negative 16. 18 and 12 are both divisible by 6. 18 divided by 6 is 3, 12 divided by 6 is 2, giving us answer choice B. Now 16 and 12 are both divisible by 4. Negative 16 divided by 4 is negative 4, and 12 divided by 4 is 3, giving us answer choice E. So B and E are both correct answers. So now you know how to factor and to use the quadratic formula if you ever need it. So just simply pick the method that you prefer and just go with that. Number 7. Which of the following answer choices is correct based on the figure shown below? So is the quantity in column A greater or the quantity in column B greater? In order to find the area and the perimeter of the rectangle, we need to solve for the missing side between A and B, which is the same as D and C. So let's go over the equations that we need. So here's the length, and let's say this is the width of the rectangle. The area of a rectangle is simply the length times the width. The perimeter is the sum of the outer segments of the rectangle. It's basically L plus W plus W, or 2L plus 2W. So right now we know the width. W is equal to 3. We need to know the length of the rectangle. So how can we solve for the missing side? Let's draw a right triangle. You need to be familiar with the Pythagorean theorem. Let's say this is A, B, and the hypotenuse is C. A squared plus B squared is equal to C squared. Now, if you know the special numbers for right triangles, you don't have to use this formula. For example, the special numbers are 3, 4, 5. There's the 5, 12, 13 triangle. There's the 8, 15, 17 triangle, and the 7, 24, 25 triangle. So since this is 3 and the hypotenuse is 5, the missing side is 4. But let's use the formula to get the answer as well. So let's call this side A. We're going to say B is 3 and C is equal to 5. So A squared plus B squared is equal to C squared. So A squared plus 3 squared is equal to 5 squared. 3 squared, or 3 times 3, that's 9. 5 squared is 25. And if we subtract both sides by 9, 25 minus 9 is 16. And the square root of 16 is 4. So as you can see, the missing side is 4. This is the 3, 4, 5 triangle. Therefore, the length is 4. So now we can calculate the area, which is the length times the width. So that's 4 times 3. The area of the rectangle is 12. Now the perimeter is 2 times L plus 2W. So it's going to be 2 times 4 plus 2 times 3. 2 times 4 is 8. 2 times 3 is 6. 8 plus 6 is 14. 14 is greater than 12. Therefore, the quantity in column B is greater. So B is the right answer. A cylinder has a height of 20 inches and a radius of 5 inches. Which of the following is correct? So is the quantity in column A greater? Is the one in column B greater? Which one? The volume of a cylinder is equal to pi r squared times the height. We have the radius. The radius is 5 inches and the height is 20. We need to calculate the volume and the surface area and see which one is larger. 5 squared is 25, and 25 times 20 is 500. So the volume of the cylinder is 500 pi. So let's just rewrite the answer right below within column A. Now the surface area of a cylinder is equal to 2 pi r squared plus 2 pi r times h. So here's the shape of a cylinder. This is just a rough sketch. And this is the radius. And here's the height. The area of a circle is pi r squared. So the area of the top circle plus the bottom circle, it's pi r squared plus pi r squared, which is 2 pi r squared. The lateral area, which is the area of the side around the cylinder, is the circumference 2 pi r times the height h. But if you don't know that, it's okay. As long as you know the equations, you can still get the right answer. So let's replace r with 5 and h with 20. So 5 squared is 25 times 2 is 50. So we have 50 pi. And in this side, 5 times 20 is 100 times 2, that's 200. So this is plus 200 pi. 50 plus 200 is 250. So the surface area is 250 pi. So clearly, we could see that the quantity in column A is greater than the quantity in column B. Therefore, answer choice A is the correct answer. Number 9. Consider the following list of numbers: 12, 17, 21, 22, 22, 26, 30, 36, and 42. So which quantity is greater, the mean or the median? The mean is simply the average of all the numbers. So if we add up 12, 17, 21, 22, 22, plus 26, plus 30, 36, and 42, the sum is 228. And if we divide it by the number of numbers that we have, there's 9 numbers. This will give us an average of 25.3. So that's the arithmetic mean. Now what about the median? The median is simply the middle number. So if we take out the first and the last number, and then the next 2 numbers, eventually we'll be left with the median. The median is 22. It's the middle number. It's always going to be the middle number as long as you list the numbers in increasing order. So therefore, the quantity in column A is greater. The mean is greater than the median. By the way, what is the mode of this list of numbers? The mode is the number that occurs most frequently. The most frequent number is 22. And finally, you need to know the range. The range is the difference between the highest number and the lowest number. The highest number is 42, the lowest number is 12, so the range is 30. Number 10. Which of the following answer choices is correct? Is the quantity in column A greater than the quantity in column B, or is it the other way around? So we have an expression on the upper right corner. X raised to the 5/3 is equal to 32. So if we can find the value of x, we can insert it into these 2 expressions, and then we could determine which quantity is greater. So let's go ahead and solve for x. So how can we solve for x in this equation? What can we do? What would you do? To solve for x, we need to change the exponent from 5/3 and we need to make it to 1. To do that, we need to raise both sides to the reciprocal of 5/3, which is 3 over 5. 5 over 3 times 3 over 5 is 1. The 3's and the 5's, they cancel. So what is 32 raised to the 3 over 5? Now you can type it in your calculator and get the answer, or you can break it down into two parts. 32 to the 3/5 is the same as 32 to the 1/5 raised to the third power. 32 to the 1/5 power is the fifth root of 32. To evaluate the fifth root of 32, ask yourself, what number multiplied to itself 5 times is 32? Now immediately you're probably thinking of 2. 2 is an even number that can most likely go into 32 5 times. 2 times 2 times 2 times 2 times 2 5 times, it turns out, is 32. And 2 to the third power, 2 times 2 times 2 3 times, is equal to 8. So that is the value of x. So therefore, x squared, which is 8 squared, is equal to 64. 7x plus 4, that's 7 times 8 plus 4. 7 times 8 is 56, plus 4, that's 60. So A is the right answer. Number 11, what is the slope of the linear equation 2x minus 5y equals 10? So what can we do here? To find a slope, we need to convert it into the slope-intercept form of the equation, which is y equals mx plus b. M, the number in front of x, is the slope. B is the y-intercept. So we need to solve for y and get it into the slope-intercept form. And then whatever number we see in front of x, that's going to be the slope of the linear equation. So let's go ahead and do that. So we have the equation 2x minus 5y is equal to 10. Now, let's move the 2x from the left side to the right side. Our goal is to get y by itself. On the left side, the 2x is positive. If we move it to the right side, it's going to be negative. Or you could just subtract 2x from both sides. So it's going to be negative 5y is equal to negative 2x plus 10. Now, in the next step, let's divide every term by negative 5. So these two will cancel, and on the left we have y. Negative 2 divided by negative 5 is the same as 2 over 5. When you divide a negative number by another negative number, it's going to give you a positive number. 10 divided by negative 5 is negative 2. So this is the linear equation in slope-intercept form. So the slope, as we can see, is the number in front of x, and that's 2 over 5. So answer choice E is the correct answer. The y-intercept is negative 2. 12. The ratio of boys to girls in a class of 400 students is 2 to 3. How many boys are in this class? So what can we do to solve this particular word problem? The best way is to set up a proportion. We're going to write 3 fractions. So the first fraction is associated with the number of boys in the class. The second one would represent the number of girls. And the third is going to correlate to the total number of students in the class. Now the ratio between boys and girls is 2 to 3. So for every 2 boys, there are 3 girls out of a total of 5 students. 2 plus 3 is 5. Now we know that the total number of students in the class is 400. Let's say the number of boys is represented by x, and the number of girls is represented by y. Now we want to find the number of boys in the class, so our goal is to solve for x. So therefore, we're going to make this fraction x over 2 equal to 400 over 5. So setting these two equal to each other, what can we do to solve for x? Whenever you have 2 fractions separated by an equal sign, you can cross multiply. 2 times 400 is 800, and 5 times x is just 5x. So now we could divide both sides by 5. 800 divided by 5 is 160. So there's 160 boys in the class. Now let's make sense of the math. There's a total of 400 students, 160 of which is boys. So 400 minus 160 is 240. So there's 240 girls. To check your answer, the ratio between boys to girls has to be 2 to 3. So let's divide the number of boys by girls. So we have 160 boys in the class, 240 girls. Reducing this fraction should give us a ratio of 2 to 3 if our answer is correct. So we can divide by 10 or cancel a 0. So 160 over 240 is the same as 16 over 24. Now both numbers are divisible by 8. 16 divided by 8 is 2. 24 divided by 8 is 3. So we indeed get the original ratio 2 to 3. So there's 160 boys in the class, 240 girls in the class. So the correct answer is A. Number 13. A jar contains 30 marbles consisting of red and blue marbles only. If there are 6 more red marbles than blue marbles, how many red marbles are there? So what can we do to find the number of red marbles? The best way to answer this problem is to set up a system of equations. So we know that there's a total of 30 marbles. That means the red marbles plus the number of blue marbles has to add up to 30. Now there's another equation that we can write. There are 6 more red marbles than blue marbles. So R is 6 more, or 6 plus B. Now we can solve this using substitution. In the first equation, let's replace R with what it's equal to, in this case 6 plus B. So if we do that, we can see that we'll have the equation 6 plus B again is equal to 30. Now we know that B plus B is 2B. And now we need to subtract both sides by 6. So 2B is equal to 30 minus 6, which is 24. And 24 divided by 2 is 12. So there's 12 blue marbles. And 12 plus 6 is 18. So there's 18 red marbles. And the question asked for the number of red marbles, not blue marbles. So the answer is 18. So C is the right answer. Number 14. A laptop sells for $399. A customer uses a 15% discount, after which a sales tax of 8% is applied. How much money will the customer spend? So go ahead and take a few minutes to work on this example. So first, we need to calculate the 15% discount. So what is 15% of $399? 15% is basically 0.15. So if we multiply $399 by 0.15, it's going to give us $59.85. So that's how much money is taken off the sale price. So we need to subtract $399 by 59.85. So the new selling price of the laptop is now $339.15. Now there's an 8% tax applied to it. So we're going to find out what 8% of 339.15 is. So let's multiply that number by 0.08. 8% is 0.08 as a decimal. To convert a percentage into a decimal, divide by 100, or simply move the decimal point 2 units to the left, and that'll give you 0.08. So multiplying those two numbers, we get 27.132. So now, if we subtract 339.15, which is the new selling price of the laptop, actually we need to add rather than subtract because this is a sales tax and the price will go up. So once we add 27.132, this should give us the final value, which is $366.282, which rounds to $366.28. So B is the right answer. Now I'm going to get the same answer using another method or technique. It helps if you understand this equation. The new price is equal to the original price times 1 plus or minus R, where R is the percentage as a decimal. So a 15% discount, you would use negative 0.15 for R because the value is decreasing. For an 8% tax, it would be 1 plus 0.08 because the value is increasing. So let me show you how to apply it. So let's start with the original price of $399. Now, to get the price after the 15% discount, multiply it by 1 minus 0.15, which is the same as 0.85. So basically, if there's a 15% discount, 85% remains. So $399 times 0.85 gives you this answer, $339.15. Now there's an 8% tax applied, so the value goes up by 8%. So it's going to be 1 plus 0.08, or simply multiplied by 1.08. And you get the final answer, 366.282. This is a much faster technique to get the right answer, because sometimes you might be given the final value and you may need to find the original value. In this case, knowing this technique can save you a lot of time. But for this particular problem, B is the right answer. A student uses a 10% coupon to reduce the price of a textbook. With a sales tax of 7%, the student pays a final amount of $216.68 for the textbook. What was the original selling price of the textbook? So using the same process, let's find the answer. So our goal is to find the original selling price. We know that there's a 10% discount. So if we take away 10% of the original selling price, that means 90% is left over. So whatever this number is, if you multiply it by 90% or 0.9, you're going to get some number here that we don't know at this point. And then whatever that number is, we're going to add 7% to the price to get the final amount of $216.68. So whatever this number is, we need to increase it by 7% or multiply it by 1 plus 0.07, which is 1.07. So if we're going from left to right, starting from the original price to the final price, we need to multiply. But if we're going backwards, then we need to divide. So to get this answer, we need to divide these two numbers. So 216.68 divided by 1.07 is about $202.50. Now, if we take that number divided by 0.9, it gives us $225. Now, let's confirm this answer. Let's work in the forward direction. So starting with 225, we're going to take 10% off. 10% of 225 is $22.50. So if you take off $22.50 from 225, that will give you a new price of $202.50. Now we need to add 7%, but first let's find what 7% is. So if we multiply it by 0.07, we'll see that 7% is about $14.18. So we need to add these two numbers. If you add 202.5 plus $14.18, you get the final price of 216.68. So we know that this is the right answer. Therefore, answer choice D is the right one. Another type of question that you'll see on the GRE math section is a numeric entry problem where there's no multiple choice to choose from. You simply have to find the answer yourself. So let's work on a few of those question types, and let's start with this particular example. The price of a certain stock is $100. In 1 month, the stock rises by 50%. 2 months later, it drops by 50%. What is the final price of the stock? So if the stock rises by 50% and then drops by 50%, does it equal its original value, or is it different? Let's find out. So let's start with $100. What is 50% of $100? 50% represents half. Half of 100 is 50. So if it goes up by 50%, the new stock price is $150. Now what if it drops by 50%? What's the new stock price now? Well, what's half of 150? Half of 150 is 75. 150 minus 75 is 75. So the final value is not 100, it's 75. And that's how math works. Now keep in mind, you can also get the answer using this equation. The new price is equal to the original price multiplied by 1 plus or minus R. So if you want to calculate this price from 100, you can use the equation 100 times 1 plus 50% is 0.5. So 100 times 1.5 will give you the 150. And now use the 150 if you wish to get the second answer, 75. Starting with 150, multiply by 1 minus 0.5. 1 minus 0.5 is 0.5. 150 times 0.5 will give you 75. So whenever something increases by 50%, multiply by 1.5. If it decreases by 50%, multiply by 0.5. That means 50% will be remaining. Number 17, a bag contains 5 red marbles, 4 green marbles, 8 blue marbles, and 3 yellow marbles. What is the probability of selecting a red marble at random? So what should we do in this problem? The probability of selecting a red marble is equal to the number of red marbles in the bag divided by the total number of marbles. So there are 5 red marbles, and if we add 5 plus 4 plus 8 plus 3, 5 plus 4 is 9, 8 plus 3 is 11, 9 plus 11 is 20. So there's a total of 20 marbles. So that's the probability. It's 5 over 20, but we can reduce it. 5 and 20 are both divisible by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. So the probability is 1/4. There's a 1/4 chance of selecting a red marble at random. Now sometimes you may need to write this answer as a decimal or even as a percentage. How can we convert a fraction into a decimal? To do that, you can use a calculator. You can simply type 1 divided by 4, and that's going to equal 0.25. If for some reason you don't have access to a calculator, you can use long division. 4 doesn't go into 1. 4 goes into 1 0 times. So we need to add a decimal. And let's add a 0. We're going to treat 1.0 as if it's 10. So how many times does 4 go into 10? 4 goes into 10 2 times. 4 times 2 is 8, and 10 minus 8 is 2. So now let's add a 0. Now how many times does 4 go into 20? 4 times 5 is 20. And so now the remainder is 0. So it's 0.25. That's how you can convert a fraction into a decimal. Now if you want to get your answer as a percentage, multiply the decimal value by 100%, or simply move the decimal point 2 units to the right. 0.25 times 100 is 25. So there's a 25% chance of selecting a red marble. Number 18. A bag contains 5 red marbles, 4 green marbles, 8 blue marbles, and 3 yellow marbles. What is the probability of selecting a green marble or a yellow marble on the first try? So if you see this key expression, you need to know what to do. To calculate the probability of selecting a green marble or a yellow marble, you need to realize that the OR statement is basically the sum of these two events. Well, it's actually one event, but the answer is the probability of selecting a green marble plus the probability of selecting a yellow marble whenever you have an OR statement. If it's an AND statement, you need to multiply the two different probabilities. But if it's an OR statement, you got to add them. Somehow you have to associate OR with the sum and AND with multiplication. So the probability of selecting a green marble or a yellow marble is simply the sum of these two individual probabilities. So what is the probability of selecting a green marble? There are 4 green marbles out of a total of 20 marbles. This problem is a continuation of the last one. If you add 5, 4, 8, and 3, you will get 20. The probability of selecting a yellow marble is equal to the number of yellow marbles, which is 3, divided by the total. Now, since the denominator of these two fractions are the same, we can add the numerators. 4 plus 3 is 7. And so the answer is 7 over 20. And this fraction is already a reduced fraction. But let's go ahead and convert it to a decimal. And at the same time, let's turn it into a percentage. So you know how to type it in your calculator. Let's use long division. So we're going to put the 7 on the inside. Whatever's on the numerator, whatever's on top, needs to go on the inside. 20 doesn't go into 7, or it goes into 7 0 times. So we need to add a decimal point and a 0. Now how many times does 20 go into 70? Well, we can make a list. 20 times 1 is 20. If you add 20 to it, you get 40. That's 20 times 2. 20 times 3 is 60. 20 times 4 is 80. And so forth. So 20 goes into 70 3 times. 20 times 3 is 60. And 70 minus 60 is 10. So let's add a 0. 20 goes into 100 5 times. If you count these numbers, you have to add 20 5 times to get to 100. So 20 times 5 is 100. 100 minus 100 is 0. And so the answer is 0.35 as a decimal. Now let's convert it to a percentage. Let's multiply it by 100%. And so the final answer is 35%. That's the probability of selecting a green marble or a yellow marble on the first try. Number 19. A bag contains 5 red marbles, 4 green marbles, 8 blue marbles, and 3 yellow marbles. What is the probability of selecting a blue marble on the first try and a green marble on the second try with replacement? So let's start with the first try. And notice that we have an AND statement. So we're going to have to multiply the probability of the two events. The probability of selecting a blue marble on the first try is equal to the number of blue marbles, which is 8, divided by the total number of blue marbles, and that's 20. Now let's go ahead and reduce this fraction. 8 and 20 are divisible by 4. So let's divide each number by 4. 8 divided by 4 is 2. 20 divided by 4 is 5. Now the probability of selecting a green marble on the second try with replacement is going to be, now you need to know what it means when it says with replacement. That means after you take out the blue marble on the first try, you're going to put it back in the bag. And then you'll select the green marble on the second try. So there's going to be 4 green marbles in the bag. And since we put back the blue marble, we still have a total of 20 marbles. Now let's reduce the fraction. Let's divide both sides. The top and the bottom part of the fraction by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. Now, to find the probability of this compound event when we have an AND statement, we need to multiply these two probabilities. So the probability of getting a blue marble on the first try and a green marble on the second try is going to be 2 over 5 times 1 over 5. Whenever you're multiplying fractions, you need to multiply across. 2 times 1 is 2. 5 times 5 is 25. So it's 2 over 25 as a fraction. Now let's convert that into a decimal. So we're going to put the 25 on the outside, the 2 on the inside. Now 25 does not go into 2. So let's put a 0. And let's add a decimal point. 25 doesn't go into 20. So we need to add another 0. Now how many times does 25 go into 200? How many quarters make up $2? 8 quarters equals $2. So it turns out that 25 times 8 is 200, and 200 minus 200 is 0, so there's nothing remaining. So 2 over 25 is equal to 0.08. And if we multiply it by 100%, this is equal to 8%. So there's an 8% chance of selecting a blue marble on the first try and a green marble on the second try with replacement. Number 20. A bag contains 5 red marbles, 4 green marbles, 8 blue marbles, and 3 yellow marbles. What is the probability of selecting a red marble on the first try and a yellow marble on the second try without replacement? So we still have an AND statement. The only difference is it's without replacement. So let's calculate the probability of selecting a red marble on the first try. The probability of selecting a red marble is going to be the number of red marbles divided by the total. So if we divide 5 and 20 by 5, we can reduce it to 1/4. That's the probability of selecting a red marble on the first try. Now, what is the probability of selecting a yellow marble on the second try? So there's 3 yellow marbles in the bag, but how many marbles in total are left over in the bag? Well, in the first try, we took out a red marble. So there's no longer 20 marbles left in the bag, there's only 19. So it's going to be 3 over 19 if it's without replacement, if we don't put back the red marble in the bag. And we can't reduce 3 over 19. Now, the probability of these two events occurring in order, like getting the red marble in the first try and then the yellow marble in the second try, to get the probability of those two events, we need to multiply these two numbers. So what is 3 over 19 times 1 over 4? 3 times 1 is 3, and 19 times 4 is 76. Now let's turn that into a decimal. So if you type in 3 divided by 76 in your calculator, you should get 0.03947 as a decimal. And if we multiply that by 100%, we can get the probability of these two events occurring without replacement. So this is going to be 3.947%. Or you could just round it to 3.9% if you want to. But that's the probability of selecting a red marble on the first try and then a yellow marble on the second try without replacement. So whenever you see the expression without replacement, make sure you decrease the number of marbles in the bag, the total number of marbles, that is. And if there's replacement, if it's a with replacement, the total number of marbles in the bag will remain the same. Number 21, a bag contains 5 red marbles, 4 green marbles, 8 blue marbles, and 3 yellow marbles. What is the probability of selecting a blue marble and a green marble with replacement? Now you might be wondering that number 21 looks the same as number 19. The total number of marbles is the same, and we're still looking for the probability of selecting a blue and a green marble with replacement. So what's the difference between number 19 and number 21? They appear to be the same, but the answer is not the same. If you want to, take a minute and rewind the video. Look at number 19. Look at the difference in the wording of the question. Number 19 asked, what is the probability of selecting a blue marble on the first try and a green marble on the second? This question doesn't specify the order of selecting the blue and green marbles, and that's important. To get the blue marble on the first try and then the green marble on the second try, we calculated the probability to be 2 over 5. The probability of getting a blue marble was 8 out of a total of 20, which reduces to 2 over 5. The probability of selecting a green marble was 4 out of 20, which reduces to 1 over 5. So the probability of getting a blue marble on the first try and a green marble on the second try was 2 over 5. This is the answer for number 19. Now, I do want to make one correction, because that's not the answer for number 19. It's actually 2 over 25. 5 times 5 is 25. So you gotta watch out for these things. Now for 21, the order was not specified. On the first try, we can get the blue marble, and then on the second try, we can get the green marble, or, remember, or is associated with some, or we can get the green marble on the first try and then the blue marble on the second try. To get the blue marble on the first try is still 2 over 5 with replacement, and for the green marble on the second try, it's 1 over 5. So this is 2 over 25. Now to get the green marble on the first try is 1 over 5 still, and to get the blue marble on the second try with replacement is 2 over 5. So this is still 2 over 25, but we need to add these two events. So the probability of getting a blue marble and a green marble with replacement when the order is not specified is twice as much compared to this answer if the order was specified. So it's 4 over 25 as opposed to 2 over 25. So watch out for that question. If the order is not specified, you need to find a probability of getting blue then green or green then blue. You have to do it that way. Number 22. Susan earns $24 per hour at her full-time job for the first 40 hours. She can work overtime and earn an hourly rate of 1.5 times her normal pay rate. What is Susan's salary if she works 56 hours this week? So here's a practical math question that you can use on a regular basis. So for the first 40 hours, she's going to earn $24 per hour. So let's multiply 40 by 24. 40 times 24 is equal to 960. And for those of you who may not have a calculator, you can do it this way. 0 times 4 is 0. 0 times 2 is 0. Add a 0. 4 times 4 is 16. Carry over the 1. 4 times 2 is 8. Plus 1 is 9. So you get 960. So for the first 40 hours, she's going to earn 960. Now, she is working for a total of 56 hours. That means 56 minus 40 is 16. So 16 of those hours she's working overtime. And her overtime rate is 1.5 times her normal pay rate. Her normal pay rate is $24 an hour. If we multiply 24 by 1.5, that's going to be 24 plus half of 24, which is 12. That's 36. So 24 times 1.5 is 36. So for those 16 hours that she's working, she's earning $36 per hour. So if we multiply 16 by 36, she's going to earn $576 extra dollars by working overtime. So now let's add these two values. 960 plus 576 is $1,536. So that's how much she's going to earn if she works an additional 16 hours overtime. As you can see, 1,500 is significantly different from 960. It's much larger. Now sometimes you might get questions that involve some form of data interpretation, as in this case. Here we have a bar graph. The bar graph below shows the annual sales of company XYZ in millions of dollars. In which year did company XYZ generated approximately 20 million in annual sales? Some questions will be simple. You just got to read the graph and get the answer. Other questions might involve calculations involving like ratios and percentages. But this one's pretty straightforward. So all we need to do is find out which year contained the sales of 20 million, and that's 2014. So for this question, the answer is C. Number 24. What was the annual sales of company XYZ in 2015? So go ahead, take a minute and try this problem. So looking at 2015, the annual sales we could see is 30 million. So therefore D is the right answer in this problem. 25. How much more sales did the company earn in 2015 compared to 2013? So what should we do in this problem? So in 2013, the annual sales, as we can see, is 15 million approximately. And in 2015, the annual sales was 30 million. So if we take the difference of 30 million minus 15 million, that gives us a difference of 15 million. So therefore B is the right answer in this problem. 26. What is the percent change in annual sales between 2015 and 2016? So there is an equation that you need in order to calculate the percent change. And it's equal to the new value minus the original value divided by the original value times 100%. The new value is the sales in 2016, which is approximately 35 million. The sales in 2015 is about 30 million. That's the original value. So it's going to be 35 minus 30 divided by 30 times 100%. 35 minus 30 is 5. And 5 times 100 is 500. 500 divided by 30 is 16.7, or 16.6 repeated. So C is the right answer. It rounds to 16.7. 27. What is the ratio of the annual sales of company XYZ from 2012 to 2015? So what should we do in this problem? How can we find the answer? Well, let's write out the 2 years. So we want to find it from 2012 to 2015. In 2012, the annual sales was 10 million, and in 2015, the annual sales was 30 million. So it's 10 to 30, and if we divide both numbers by 10, we can see that the ratio 10 to 30 is the same as 1 to 3. So the correct answer is B and not E. You have to write this in the appropriate order. 28. The annual sales of company XYZ is projected to grow 8% every year for the next 5 years. According to this information, what is the expected annual sales in 2021? So how can we figure this out? Well, let me show you what not to do. You don't want to multiply 8% by 5 and use 40% as your as part of your calculations. So if you multiply, let's say 35 million, which is the sales in 2016, because we're starting from 2016 and we're going to calculate the annual sales in 2021. So we got to start from this number. So if you take 35, and because it's an increase of 40%, 1 plus 0.4, that's 1.4. 35 times 1.4 is 49. The answer is not B. This is not the appropriate way to do it. Instead, let's find 8% of 35 and calculate the answer each year from there. So 35 times 8%, or 0.08, that's equal to 2.8. So in the first year, the annual revenue will increase by 2.8. So it's going to be 37.8. Now keep in mind, you can get that same answer using this equation. The new value is equal to the original value multiplied by 1 plus or minus r. So using this equation, we can get the annual sales in 2017 by taking 35 and multiplying it by 1 plus 0.08, since it's going up 8% every year. So 35 times 1.08 is 37.8. So now, if we want to find the annual sales in 5 years, we just need to multiply 35 by 1.08 5 times, or just raise it to the 5th power. So 35 times 1.08 raised to the 5th power is equal to 51.4. So therefore, the annual sales in 2021 is going to be 51.4 million. So C is the right answer. Number 29. What is the area of the shaded region? How can we figure this out? The area of the shaded region is the difference between the area of the square and the area of the circle. So I'm going to say area of SH, that's the area of the shaded region, is the area of the square, SQ, minus the area of the circle. So if we can find the area of these two objects, then we could find the area of the shaded region. The area of the square is simply side squared, where S is the length or the width of each side of the square. All sides are the same for a square. The area of a circle is basically pi r squared. And we have the radius. The radius of the circle, we could see it's 5. The radius is half of the diameter. It's the distance between the center of the circle and any point on the edge of the circle. Notice that the diameter is the same as S. So therefore S is twice the value of the radius. It's 2 times r. So 2 times 5 is 10. So each square has a side length of 10. So the area of the shaded region is going to be 10 squared minus pi times 5 squared. 10 squared, or 10 times 10, is 100. 5 squared is 25. So the answer is 100 minus 25 pi. Now we may need the answer in decimal form, since this is a numeric type question, a numeric entry question. Pi is about 3.14, but you want to use the exact value in your calculator. Pi is about 3.14159. So 100 minus 25 pi, if we change it to a decimal, is about 21.46. And so this is the area. Number 30. What is the area of the figure shown below? So what can we do to find the area? The best thing that we can do is decompose this composite figure into two smaller figures. So let's draw a line. So we could turn it into a rectangle and a triangle. The height of the triangle is 5. These two are the same. And what is the base of the triangle? Keep in mind 14 is the entire length of this segment, which means 10 is this portion. The base of the triangle is only 4, because 10 plus 4 adds up to 14. Now the area of a rectangle is equal to the length times the width. The rectangle has a length of 10 and a width of 5. 10 times 5 is 50. So the area of the rectangle is 50. Now what about the area of the triangle? The area of a triangle is simply 1/2 times the base times the height. The base, we could see it's 4. The height of the triangle is 5. 4 times 5 is 20. Half of 20 is 10. So the area of this region is 10. So the total area of the figure is 50 plus 10, so it's 60. This is the answer. Number 31. Which quantity is greater? Is it A or is it B? So we're given this expression, 2x minus 3y times 2x plus 3y is equal to 12. So using that information, how can we determine which column contains the greater quantity? And what is the value of 4x squared minus 9y squared? Notice what happens when we multiply these two expressions. Let's FOIL it. Two x times 2x is 4x squared. 2x times 3y is positive 6xy. Negative 3y times 2x is negative 6xy. Negative 3y times 3y is negative 9y squared. All of that is equal to 12. Positive 6 and negative 6 adds up to 0. So notice that 4x squared minus 9y squared is equal to 12. So column A has a value of 12. Column B has a value of 16. Therefore, the quantity in column B is greater. So answer choice B is the right answer. 32. Which quantity is greater? Is it A or B? So we know that x is somewhere between 0 and 1. X cannot equal 0 and it cannot equal 1. It can be 0.1, 0.5, 0.9, but not 0 or 1 or any number outside of that. So what we're going to do is try 3 numbers. And we're going to see if we can determine the relationship between A and B. So this is going to be the x value that we're going to choose. Here we're going to have the value of 1 over x squared. And then the value of 1 over x. So let's choose 3 numbers, 0.1, 0.5, and 0.9. When x is 0.1, the value of 1 over x squared, which is 1 over 0.1 squared, that's equal to 100. 1 divided by 0.5 squared is about 4. 1 divided by 0.9 squared is 1.234, or 235 if you round it. Now 1 over x, 1 divided by 0.1 is 10. 1 divided by 0.5 is 2. 1 divided by 0.9 is 1.1 repeated. So as we can see, notice that the column in the middle is always larger than the column on the right side. So 1 over x squared is greater than 1 over x if x is between 0 and 1. So therefore, the quantity in column A is greater. So answer choice A is the right answer. Number 33. Which quantity is greater? Is it 16 to the third power or 8 to the fourth power? How can we find out without the use of a calculator? The best way to do this is to convert it into a common base. How many 2's do we need to multiply to get to 16? It turns out that 2 times 2 times 2 times 2, 4 times is 16. So 2 to the fourth is 16. And for 8, you need to multiply 3 2's to get to 8. So we can replace 16 with 2 to the fourth. So 16 cubed is 2 to the fourth raised to the third power. And 8 to the fourth is basically 2 to the third, but raised to the fourth power, which is 8 to the fourth. Whenever you raise one exponent to another exponent, you can multiply it. So 16 cubed is the same as 2 to the 12th power. 8 to the fourth is also 2 to the 12th power. So as we can see, the two quantities are equal. Now, if you have access to a calculator, you could simply type these numbers in. If you type in 16 raised to the third power, you should get 4,096. And if you type in 8 raised to the fourth power, this will give you the same number. So this is the best way to do it if you have access to a calculator. But it's also important to understand how to change from one base to another. So C is the right answer for this problem. 34. Which quantity is greater? Is it the one found in column A or in column B? And keep in mind, x is a positive number greater than 1. So let's start with column B. X squared raised to the 9th power. This is equal to x raised to the 18th power. 2 times 9 is 18. Anytime you have an exponent raised to another exponent, you should multiply. So now let's focus on the information found in column A. So what is x cubed raised to the 4th power? 3 times 4 is 12. And what's x to the 6th times x to the 12th? When you multiply two common bases, you should add the exponents. 6 plus 12 is 18. Therefore, the two quantities are equal. So C is the right answer. 35. X is between 10 and 16, and Y is between 8 and 12. So which quantity is greater? The product of X and Y or 120? So let's make a list. Let's choose some values and let's see which one is going to be larger. So let's choose the lowest possible values of X and Y. Even though X cannot equal 10, it could be very close to it. It could be like 10.01. But for all practical purposes, let's choose 10 and 8. If X is 10 and if Y is 8, the lowest possible product of XY is 80. So keep in mind, XY is just above 80. It's not exactly 80, but very close to it. Now, on the high side, when X is 16 and Y is 12, let's see what the product is going to be this time. 16 times 12 is 192. So notice that 180 is less than 120, which is the quantity in column B. But 192 is greater than 120. So sometimes XY is less than 120, sometimes it's greater than 120. So we don't have a consistent relationship So we can't say the quantity in column A is greater than that of B, because that's not always true. In the first case, when x is 10 and y is 8, xy is less than the quantity in column B. But in the second case, it's greater than. So D is the right answer. No consistent relationship can be determined from the information given. Sometimes quantity A is greater, sometimes quantity A is less than B. There's no consistent relationship. The video that you're currently watching is a trailer version of a longer video. This video only contains the first 40 multiple choice problems out of a total of 135. So if you want the rest of the problems, feel free to check out the link that's posted on the screen, and you can find the rest of the video. So now let's move on to the next problem. 36. Mary can make 12 cupcakes in 5 minutes. How many cupcakes can she make in 2 hours? So how can we solve it? Well, first, let's determine how many minutes are in 2 hours. 1 hour is equal to 60 minutes, so 2 hours is equal to 120 minutes. So we need to find out how many cupcakes can she make in 120 minutes. So what we can do is set up a proportion. On the left side, we're going to put the information for the number of cupcakes, and on the right side, the unit of time in minutes. So let's write two fractions separated by an equal sign. So she can make 12 cupcakes in 5 minutes. We want to know how many cupcakes she can make in 120 minutes. So let's cross multiply. 12 times 120 is 1440. 5 times x is simply 5x. To solve for x, we need to divide both sides by 5. So 1440 divided by 5 is 288. So in 120 minutes, or 2 hours, she can make 288 cupcakes. So answer choice B is the right answer. Now we can get the same answer using conversions instead of a proportion. The conversion factor is given to us. She can make 12 cupcakes in 5 minutes. So we can say that 5 minutes is equal to 12 cupcakes. Our goal is to convert 2 hours into the number of cupcakes. So let's start with 2 hours. Now let's convert hours into minutes. Since we have the unit hours on the top left, we need to put the unit hours on the bottom right. And then we'll put minutes on top. So 1 hour is 60 minutes. Now we can convert minutes into cupcakes. We know that for every 5 minutes, she can make 12 cupcakes. So notice that the unit hours cancel and the unit minutes cancel, leaving behind cupcakes. If you do it this way, you can get the answer, and also pretty quickly too. So 2 times 60 times 12 is 1440 divided by the number on the bottom, which is 5. And that's going to give you 288. So answer choice B is the right answer. 37. A certain vehicle can travel 125 miles using 6 gallons of gasoline. How many gallons of gasoline are required to make a trip of 1,500 miles? Now you can solve it using a conversion process or using a proportion. Let's solve this problem using proportions. So we have miles and the number of gallons. So using 6 gallons of gas, the car can make a trip of 125 miles. And using an unknown amount of gas, it can do 1,500. Let's calculate that unknown amount. So 125 times x is 125x, and 6 times 1,500, that's 9,000. So now let's divide both sides by 125. 9,000 divided by 125 is 72. So therefore, this particular vehicle uses 72 gallons of gas to make a trip of 1,500 miles. So answer choice C is the right answer. 38. One jar can hold 16 cupcakes, and 11 cups of flour are needed to make 5 cupcakes. How many cups of flour are required to make enough cupcakes to fill 12 jars? So let's write out what we know. The first conversion factor relates the number of jars to the number of cupcakes. So one jar can hold 16 cupcakes. The second conversion factor relates to cups of flour to the number of cupcakes. Since we have multiple steps in this problem, it's best to solve it as a conversion, not using proportions. So we know 11 cups of flour can make 5 cupcakes. We need to convert the number of jars into the number of cups of flour. So using the number of jars, we can calculate the number of cupcakes it can hold, and using that, we can calculate the number of cups of flour that are required. So let's begin with what we're given. We're given 12 jars, and we want to convert that to the number of cups of flour. So let's convert jars into cupcakes using the first conversion factor. So we need to put the unit jars on the bottom, cupcakes on the top. The number that correlates to jars is 1, and the number that is associated with cupcakes is 16. One jar can hold 16 cupcakes. So the unit jars cancel. Now we can convert cupcakes into cups of flour, and the ratio is 5 to 11. So for every 5 cupcakes, 11 cups of flour are required. So these units cancel as well. So it's going to be 12 times 16 times 11 divided by 5. So as a decimal, it's about 422.4 cups of flour. So that's the answer. Alright, let's try 39. Sarah can paint 2/9 of an entire house using 3 cans of paint. How many cans of paint are required to finish the rest of the house? So for this problem, let's set up a proportion. So on the left side, we're going to have the cans of paint, and on the right side, the fraction of the house that she's going to complete. So using 3 cans of paint, she can do 2/9 of the entire house. The rest of the house is the other 7/9. 2/9 plus 7/9 is 1 whole. That's 9/9, which is 1. We need to find out what value corresponds to 7/9, or the rest of the house. Now to simplify the fraction on the right side, we can multiply the top and the bottom by 9. Whatever you do to the top, you must also do to the bottom. If you do that, the value of the entire fraction remains the same. 2/9 times 9, the 9's cancel, so you just get 2. 7/9 times 9 is simply 7. So now we have this fraction, 3/x is equal to 2/7. Now let's cross multiply. So we have 2x is equal to 3 times 7, which is 21. So now let's divide both sides by 2. So the answer is 21/2. That's how many cans of paint she needs to finish the rest of the house. Half of 21 is about 10.5 as a decimal. So she needs 10.5 cans of paint to finish the rest of the house. Number 40. It takes John 3 hours to paint 15% of a house. How long will it take him to finish painting the rest of the house? So let's begin by setting up a proportion. So we have time and a percentage of the work done. So it takes him 3 hours to finish 15% of the house. That means to finish the rest of the house, that is related to 85%. To finish the entire house, that's 100% of the job. So 100 minus 15 is 85%. So how long will it take him to finish the remainder, 85% of the job? So that correlates to x, so we got to solve for x. The unit percentage will cancel, so we don't have to worry about it anymore. 15 times x is 15x, and 3 times 85, that's 255. Now let's divide both sides by 15. So 255 divided by 15 is 17. So x is equal to 17. So it's going to take John 17 hours to finish 85% of the house, which is the rest of the house. And so that's the answer to this problem.